Welcome back to another Python tutorial. In today's video, we're going to be creating a program that tests to see whether a number is prime or not. So we know a number is prime if its only factors are 1 in itself. So for example, for the number 17, we know this number is prime because it only has the factors of 1 and 17. If we take a look at another number, like for example the number 8, we know this number is not prime because it has the factors of 1, 2, 4, and 8. So it has other factors rather than 1 and the number itself. So in our program, what it needs to be able to do is check the numbers between 1 and the number itself to see if these other factors exist. Okay, so let's get started on this. The first thing we're going to do is define a variable called number, and we're going to set this equal to the number 17. Since we're going to be going through a sequence of numbers, we can use a for loop to do that. So we'll say for I in range, and then we want to start at 2 and go all the way up to the number. So this will go between 2 and 1 less than the number itself. For the number 17, it'll go between 2 and 16. To see that, let's go and start by just printing off the value of I. And we see we have a list of numbers between 2 and 16. So next, what we need to do with these numbers is check to see whether they're factors of 17. We can do that by checking to see if number modulo I is equal to 0. So what this is doing, it's taking number, dividing it by I, and checking to see what the remainder is. So this percent sign, once the division occurs, it lets you know what the remainder is. So we're checking to see if that remainder is equal to 0, which would mean that I is a factor of number. Okay, so if we do find a factor, we're going to print that that number is composite. And then after it looks through all those numbers, if it doesn't find a factor, then we're going to say else, and we're going to print that the number is prime. Okay, let's go ahead and check it out. So for 17, it prints off prime, just like we expected. Let's try a composite number. So let's try 24. And if we run our program, we see that we have composite printed a bunch of times. So what we need to do is once it finds one factor, we don't need to keep looking for other factors. What we can do is write the word break here, so that once it finds that first factor, we can just stop. Now if we run it again, it just prints composite one time. This is one way to check to see whether a number is prime or not, but it's actually over-checking. So what we're going to do is modify this a little bit so it doesn't have to look through so many numbers. And down here what we're going to do is just a couple examples to illustrate what we're about to do. Let's go ahead and start by taking a look at 24. And we'll go ahead and just list the factors. So 24 has factors of 1, 2, 3, 4, 6, 8, 12, and 24. So the way our program is written right now, it would look between the numbers 2 and 23 to check for factors, but we don't actually have to check all those numbers. We can actually divide this list of factors in half, for example, just taking the first half, and that would be enough. The reason for that is each number in the second half here pairs with a number in the first half. So for example, 2 pairs with 12, 3 pairs with 8, and so on. And because of that, we can actually reduce the range of our for loop to be able to check through fewer numbers, but accomplish the same goal. And the way we're going to do that is by taking the square root of the number and just looking between 2 and the square root of the number. So the way we have to modify our program up here is we're going to first import math so that we can use the square root function. And then after that, we're going to take the square root of this number, and we can do that by saying math dot square root, and then put the number in parentheses. And we're going to do one additional thing to this. So right now this number is a float, but we want to convert it into an integer. So to do that, we're just going to put int right here, and then enclose it in parentheses. So first it's going to take the square root of the number, but it'll be a decimal version of it. So we're just using the in function to convert it to an integer. And then we actually have to include +1 right here. And the reason for that, let's take a look at the number 25. The number 25 has factors 1, 5, and 25. So if I took the square root of 25, it would give me the number 5. And without that plus 1, the range would be between 2 and 4. And if I tried to run that program, it would tell me that 25 is prime because it doesn't actually check the number 5. So if we didn't include this plus 1, it would check between 2 and 1 less than the square root of the number. So by adding that plus 1, it actually goes between 2 and includes the square root of the number as well. Okay, let's go ahead and run our program and check it out. So it tells me that 24 is composite. Let's go ahead and try 17 like we saw before. It still tells me that 17 is prime. And let's go ahead and just try a random number. So this number is composite. And it would be interesting to know what the factors of this number are. So what we can do is down here, after it prints composite, let's go ahead and print I. And then we're going to do number divided by I. Okay, now let's run our program and take a look. So for this number, it's composite, and one factor pair is 19, and 24,919,000 and 913. Okay, let's try another number. So this number is composite. One of its factors is 3, and the other one is this big number right here. Okay, so in this video, we created a program that's able to test to see whether a number is prime or composite. I hope you enjoyed, and stay tuned for the next one.